Hey, welcome back to MedMadness. You are tackling public health on Usmle Step 1. There is no escaping the world of statistics. But don't worry, it doesn't have to feel like math class. Today we are breaking down the statistical concepts in a way that actually makes sense for med school and the exam. Let's get into it. So first up, measures of central tendency. You have seen these a million times. The mean is the average, the median is the middle value, and the mode is the most frequent number, right? And here is what matters. When your data is normally distributed, the mean, median and mode are all the same. But in the skewed data, they shift. In a positive skew, the mean is pulled to the right. In a negative skew, it is pulled to the left. Then we have got measures of spread or dispersion. Standard deviation tells you how spread out the values are, and standard error tells you how precise your sample mean is. It gets smaller as your sample size gets bigger. The formula: standard error is equal to standard deviation divided by square root of n. Simple. Now the normal distribution, and this shows up all the time. Remember this rule: 68% of values lie within 1 SD, 95% within 2 SD, and 99.7% within 3 SD. And that's the classic bell curve. It's a favorite for USMLE exam. Next, let's talk about hypothesis testing. It always starts with the null hypothesis. This says there is no difference or no effect. The alternate hypothesis says there is a difference or effect. If your p-value is less than 5% or say 0.05, you reject the null hypothesis. Again I repeat, if your p-value is less than 0.05 or say 5%, you reject the null hypothesis. And this means it is statistically significant. Very important term, right? So if your p-value is less than 0.05, you reject the null hypothesis, and this is statistically significant. Now here is where things get juicy. A type 1 error or say alpha error is a false positive. You said there was a difference when there was not. Again I repeat, so you said there was a difference when there was not. Fine. And type 2 error beta is a false negative. You missed a difference, but that was actually there. Fine. So you draw a 2 by 2 table and check, and you will understand. Fine. So type 1 error is alpha and type 2 error is beta. And alpha is false positive and beta is false negative. Your ability to detect a true difference is called the power, and the power is equal to 1 minus beta. You can increase the power by increasing the sample size, increasing the effect size, and decreasing variability. Let's slide into confidence intervals. These give a range where the true value probably lies. For example, 95% confidence interval means we are 95% confident the real number is in that range. If a confidence interval for mean difference includes 0 or a confidence interval for risk ratio includes 1, it is not statistically significant. Last up, correlation and regression. Correlation measures how two variables move together. It ranges from -1 to +1. R square or the coefficient of determination tells you how much one variable is explained by the other. Again I repeat, how much of one variable is explained by the other. But remember this, correlation doesn't mean causation. This is important. Just because ice cream sales and shark attacks both go up in summer, it doesn't mean one causes the other. Am I right? So here is a big picture. Stats are not about numbers, they are about meaning. Know your distributions, understand how to spot type 1 and 2 errors, and always think, what is this result actually telling me? Nice work. Take a breather, review the basics, and get ready for what's next. You are doing great, and MedMadness is right here with you every step of the way. I'm Dr. Ram here. See you next podcast.